Okay, in this problem we're asked to see whether a precipitate will form, and we're told that we're going to be mixing together copper 2 nitrate and sodium sulfide. And so if you like, just to give you an idea of what we're doing here, I'm going to skip right to the net ionic equation. But we're mixing together this copper ion and the sulfide ion. Of course, this is the pertinent part. And we're going to make copper 2 sulfide. And of course, maybe we're not going to make it after all, right? That's the question. Is the precipitate going to form? Well, the KSP is just, of course, the reverse of this reaction here. So we talk about KSP, we're asking ourselves whether this precipitate or would-be precipitate is actually going to remain dissolved in the solution. And I'm not sure why the pen did that just now, but that's okay. And so the KSP here is very small, right? So that's telling us that this compound copper 2 sulfide is highly insoluble. And we might just hazard a guess by looking at the molarity of the copper 2 nitrate and the sodium sulfide that we're not going to, we're not going to be able to remain dissolved at this concentration. We're going to go ahead and probably form a precipitate, but we can go ahead and do the math to prove it. The next thing that we have to recognize is that it's giving us our concentration of the sodium sulfide here and the copper 2 nitrate, but we need to remember that when we mix the two solutions together, we pour one beaker into the other, or the contents of one beaker into the other beaker, we're going to end up effectively doing a dilution. And because the volumes are equal, we have 50 milliliters of each one, the final volume of sulfide, or excuse me, the final concentration of sulfide is going to end up being 0.1 molar, and the final concentration of the copper ion is going to be 0.050 molar. And so what we have now is the ability to find Q. And so Q will equal the concentration of copper ion, there we go again, times the concentration of sulfide ion. And Q here is going to equal 0.050 times 0.10. And Q is going to work out to be 5.0 times 10 to the minus 3. Now, as we always do, we're going to come back and seek to compare Q to K. And here we see that Q is much, much larger than K. Of course, I'm talking about the KSP value. The KSP value is around 1 times 10 to the minus 36, and we're 5 times 10 to the minus 3. So here Q is way larger than K, so yes, the precipitate will form, and we've been able to show it.